Hi everyone, in this video I'm going to explain how to solve higher degree polynomial inequalities. I'm going to show this by 6 different examples. Let's start. The first one, solve the inequality x minus 3 times x plus 1 times x plus 7 less than 0. Okay, how to solve this one? Again, the logic is the same, guys. At first we have to find critical points, and here this one is easy because all the products are given for this polynomial. Then we can find critical points easily. So x minus 3 is 0, then x1 is 3. Okay, the first step. And x plus 1 is 0, then x2 is minus 1, and finally x plus 7 is 0, then x3 is minus 7. There are 3 critical points. And the next step, drawing the table. Okay, let's draw the table. Okay, here, okay, x minus infinity, let me draw a little bit longer, okay, plus infinity, and here, okay, let me write just e, okay, is equal to, let's say, is equal to e, and I'm going to write e, just e here, because it's so long, I don't want to write here. Then we have to write the numbers. 3 is first, right? No, absolutely no, because we have to write the numbers respectively. The first one is minus 7 because it is the least one. Okay, the least one is minus 7, the middle one is minus 1, and the biggest one or greatest one is 3. Okay, now this one makes 0 the expression. Okay, these are the zeros of the polynomial. Okay, and then first sign. What is first sign? Here, okay, you can give any value, for example, greater than 3. For example, let's give a value greater than 3. For example, maybe 4. 4 minus 3 is a positive number. This one is positive. Okay, 4 plus 1 is 5, so it is another positive value. 4 plus 7 is 11. It's another positive value. Then positive times positive times positive is positive, so then the first sign is positive. Or actually, if you multiply them, the leading term becomes x cubed, and sine of x cubed is positive here, so the first sign becomes positive. You can check this one, or just sine of x is here, positive, 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 so the first sign is positive. And here we have to change the sign, negative and positive and negative here. Okay, so what are we looking for? The negative signs, less than 0, because the expression must be less than 0. Now let's shade with the black one this time. Okay, less than 0 here and also here. Okay, so x is element of from minus infinity to minus 7. Okay, the solution set doesn't include the 7, minus 7, union, and again minus 1, okay, with open parentheses, and here 3. Okay, yeah, this one is our solution, as you see. Okay, let's repeat this one. The first step, finding critical points. The second one, table, and you have to decide the first sign. It is important, and also here writing equation, writing solution set. Okay, now let's go on with the second one. Here we have x cubed. Nice. Okay, at first we have to factorize this one, and we have to find out the factors. Okay, with factorization, now let's find out them. So if you factorize this one, this expression with x at first, so it becomes x squared minus 4. Okay, so then, okay, let's write the equation here. X times x minus 4 equals 0. X squared minus 4, sorry. And so we can factorize this one also. One more time. X times x minus 2 times x plus 2. Nice. Is equal to 0. Then actually we can see the critical points. Okay, the first one is x1 is 0. And the second one is x2. Okay, it is 2. And the third one is minus 2. Okay, now, okay, let's draw the table. So x minus infinity, and plus infinity again. Here let's write the roots here, critical points. Okay, minus 2 is the least. Okay, minus 2, and the other one, middle one, is 0, and the number 2 is the last one. Okay. Okay, now again I'm gonna write e. You may write p anyway. Okay, e is equal to, okay, now this one is 0 and this one makes 0 here. Okay, now what about the first sign? Here first sign is again positive. It depends on the sign of x cube here. The leading term is x cube, as you see. The first sign is positive. Or you may write any number instead of x, which is greater than 2 exactly. Okay, let's write here, for example, 3 or 4. Let's write 4, for example, here, and also here, anyway. 4 times 4 squared. Okay, 4 squared is 16 minus 4. So this one is positive, and this one is also positive. A positive value times another positive value makes positive. Okay, the first sign is positive. And here negative, here positive, and here also negative again. Okay, now here let me draw and let me use purple one. Okay, now less than or equal to 0 again. Less than or equal to, interesting anyway. Okay, this one is, okay, this part is solution set, and also this part is solution set. Okay, now what about the critical points? Okay, minus 2 is solution. Yes, exactly, because here we have a less than or equal to, so minus 2 is solution. Okay, minus 2 is solution, and 0 is solution, and 2 is solution. Okay, and if you want to show this one with number line, it's gonna be like that. By the way, let's show this one. Okay, this time, only this time. Okay, minus 2 is closed, minus 2 is closed, 0 is closed, okay, and 2 is closed, like this. Okay, 0, sorry, this one 0, okay, and this one is 2. Okay, so these numbers are solution, okay, here, and also these numbers are solution. Okay, members of solution set. Okay, and then how can we just describe these parts? Okay, from minus infinity to minus 2, but it should be like this, closed, and okay, 0 is closed again, and 2 is also closed. Okay, now let's write x element of all real numbers less than minus 2 or equal to minus 2 union, okay, or the all real numbers between 0 and 2, and also 0 and 2. Okay, this is our solution set. Okay, what about the next? Let's see that. Okay, 4 minus x4, interesting. Okay, let's see that. Okay, now let's factorize this one. At first, how can we write this one? Okay, so 4 minus x4 is equal to 0. Okay, this one is 2 squared, and this one is x squared, quantity squared, is equal to 0. Then let's factorize with like that. 2 minus x squared times 2 plus x squared, okay, is equal to 0. Okay, then this part, okay, we cannot factorize this part. And what about the first part? Yes, we can factorize one more time. So it is going to be square root of 2 minus x times square root of 2 plus x, or you can find the values by using different way. Okay, let's show how 2 plus x squared is equal to 0. Then if you want to, if you cannot see this one, okay, let me write here 2 minus x squared is equal to 0. Okay, I'll think about this one. This one is 0, or this one is 0. This one cannot be 0. You know this one. Okay, so it is always positive. So this one can be 0. So x squared is equal to 2. Then which number square is 2? There are two values here. x1, 2 is plus minus square root of 2. Yeah. Okay. And also here, so square root of 2 minus x is equal to 0, or square root of 2 plus x is equal to 0, or okay, 2 plus x squared is equal to 0. The first one is square root of 2, or the second one is minus square root of 2, and here no real solution, no real solution. Okay, then there are two solutions. Good. There are two solutions, I mean there are two critical points. Okay, minus infinity. Here we have to write them respectively, minus square root of 2 and plus square root of 2 and plus infinity. Okay, now this one, okay, less than or equal to again, anyway. Okay, 4 x to 4, yes. Okay, here this one makes 0 the expression and this one makes the expression. Now this time is important. Sign of leading term. What is leading term? Minus x to 4. So sign of a leading term is negative. So this one is negative. What about here? Positive. And here negative again. Then here, which part is solution? Okay, which part is solution? Okay, now let's draw with red. This one. And also the number square root of minus square root of 2 and the square root of 2 and this case. Okay, so let's write x element of from minus infinity to minus square root of 2, okay, union square brackets, okay, and here from square root of 2 to plus infinity, plus square root of infinity, square root of 2 or square root of 2 anyway. Okay, to positive infinity. Okay, let's go on. The next. Okay, again x cubed, this time greater than 0, but here we have minus x cubed. Anyway, at first you may factorize this one with x. Let's see that. Okay, with minus x, if you factorize this one minus x times, so it becomes x squared minus 4x and plus 4. Okay, let's write is equal to 0 to see critical points. So minus x times, okay, this one is x minus 2 quantity square is equal to 0. Okay, nice. So minus x is equal to 0, or x minus 2 parentheses square 0. Okay, so x1 is 0. The first root is 0. What about here? That is double root. Okay, guys. So x minus 2 is 0, then let's write x2 and 3, okay, is equal to 0. That's double root. Don't forget that. It's important. Okay, now let me draw the graph of table. Okay, here, minus infinity, 0, 2, and plus infinity. Don't forget that. At point 2, there is double root. Okay, this one makes 0. Now let me write here is equal to p. Okay, polynomial. Okay, p. Now here, this one is double root. Okay, then sine. Okay, sine of leading term. Sine of leading term is negative. This one is negative. This one is positive, right? No, exactly no. So we cannot change the sign because here we have double root. So it is also negative. And here positive. This part is positive. Oh, so good. Okay, now, okay, where is the solution set? Okay, greater than 0. This part is greater than 0. Nice. Just, okay, x is element of only this one. From minus infinity to 0. Okay, just negative numbers. Just negative numbers are solution set. Okay, next one. X to 4. Interesting. X to 4 minus 10x squared plus 9. Oh, how can we solve this one? Okay, here. Actually, you may change this term with t squared. But anyway, okay, let me write x to 4 minus 10x squared plus 9. Okay, let me write here x squared and x squared. Product of x4, products of x4, and here let's write products of 9, maybe 3, but I think it's impossible. Let me write here 9 and 1 at first. Okay, here. But if you multiply and add them, you cannot get minus 10x squared. But if you write here negative and here also negative sign. Okay, now let's check. X squared times minus 9. Okay, so it becomes minus 9x squared. And here x squared times minus 1, so it is minus x squared, and if you add them, it becomes minus 10x squared. Nice, I like it. Okay, so we can factorize this one as x squared minus 9 times x squared minus 1. Wow, is equal to 0. Okay, is equal to 0. Okay, then we can factorize this one. It's the difference of two squares again. So x minus 3 times x plus 3, and here x plus 1 times x minus 1. There are 4 different roots. Good. Okay, 0. So I'm writing the roots directly. Okay, x1 is equal to 3, or x2 is equal to minus 3, or x3 is equal to minus 1, or x4 is equal to 1. Okay, now let's draw the table. Okay, let's draw the table longer. Okay, x minus infinity. Here now the numbers are important here. Minus 3 is the least one, minus 3, and later minus 1, and next one is 1, and 3, and plus infinity, exactly. Okay, again, let's say p here. So p, it's p. Now this one makes 0, this one makes 0, this one makes 0, and also this one makes 0. Okay, 4 zeros, nice. Then sine of x4, okay, it is positive. The next line, okay, there is no double root as you see, so we have to change signs. Negative, positive, negative, positive. Nice. Okay, we are searching positive values because, okay, look at you now, greater than 0. This part is positive. This part is also positive, and also this part is positive. Okay, here we have 3 parts. Okay, now let's write x is element of, I can change the color by the way. Okay, x is element of, okay, minus infinity to minus 3, union. Okay, why I'm using parentheses, because here we have just greater than 0, not greater than or equal to 0. Okay, minus 1 to 1. Okay, and union from 3 to plus infinity. Okay, now this is our solution set. What about the next? Okay, oh, it is the big one, greatest one. Okay, anyway, it's not a problem because the way is the same actually. We have to find the critical points, we have to decide the sign, and so on. Okay, now the first one. Okay, let's write the expression here. I'm going to write again p here. So p is equal to, okay, x to 5, okay, times 6 minus x times x plus 1 squared. Critical point. Okay, double critical point. Okay, 3x plus 8, okay, is equal to 0. Then if x5 is 0, then x1 is equal to 5. Is it double root? Oh, okay. Oh, sorry, 0. It is 0. Is it double root? No, because guys, if the power is even, like 2, 4, 6, 8, and so on, so it is double root. So this number is double root, for example. I mean, minus 1 is double root here. But if the power is odd, okay, there is no double root. Okay, or 6 minus x is 0. Careful, sign of x is negative here, so x2 is 6, and here also this one is critical point, double critical point, because it is square. So x plus 1 is 0, then x3 is okay, moment, okay, let's clean this one, let's write good, better. Okay, x3 is minus 1, right? Okay, minus 1. We may write x3 and x4. Okay, double root because of this one. Okay, so 3x minus plus 5. Oh, plus 8. It's a little bit strange, but anyway. Okay, 3x plus 8 is 0. Then 3x is equal to minus 8. X is equal to x5. Let's say x5 is equal to minus 8 over 3. Minus 8 over 3. Yes. Okay. Yep. Okay, now let's do the table. Okay, here like that. Okay, x minus infinity. Now which one is the least? Oh, minus 1 or minus 8 over 3? Minus 8 over 3 is minus 2 point something, not minus 3. Okay, but it is less than minus 1, so it is the least. Minus 8 over 3. And the next one is minus 1. Careful, minus 1 is double root, don't forget that. Okay, the next one is 0. And the last one is 6. And plus infinity. Okay, now this is p. Okay, this one makes 0, this one makes also 0, but here we have double root. Okay, we will not change this one, and here we have 0 again, and here we have 0. Now I'm gonna change this one. Let's say, okay, greater than or equal to 0, greater than or equal to 0. Okay, greater than or equal to 0. Okay, what about the first sign? It's a little bit hard. Sign of here. Actually, how can we get the leading term? We can multiply these to unknowns, and we can see them actually. Okay, x to 5 times minus x, so it becomes minus x to 6, times x minus x to 7. And, oh, sorry, here we have x squared, because here we have square, so x squared, okay, minus x to 6, minus x to 8. And if you multiply 3x, minus 3x to 9, it's like that. So it is negative actually, but also just you may write the signs of x's here. So the first one is positive times the second one is here negative. Okay, sign of x, just a sign of x, and here it should be positive because here we have x squared, so it is positive, and here 3x, it is also positive, and that means, okay, times plus times minus times plus times plus, so the first sign is negative. The result is negative, then the first sign is negative. Okay, here what about the next one? Positive, and here negative. Careful, it is also negative. Careful, it's also negative, and it is positive. Okay, positive. What about greater than or equal to 0? Yeah. Okay, greater than or equal to 0. This case is critical. Okay, this one is greater than 0. Okay, and this is equal to 0. We have to take this number to set. Okay, then this case is also positive. Yes. Okay. And okay, and okay, do we have and? Yes, we have and. What is that? The number minus 1 is also solution. Don't forget this one, because here we have greater than or equal to 0. Okay, the numbers between minus 8 over 3 and minus 1, not solution. And the numbers between minus 1 and 0, okay, they are not also solution. I know that. But the number minus 1 is solution. Okay, this case is important. Okay, so we can write this one as x is element of the numbers from minus infinity to minus 8 over 3 union just the number minus 1. How can we write this one? Like that. Just the number minus 1 and union from, okay. Oh, square brackets. Okay, sorry, square brackets. Okay. And this one also like that, because it's greater than 0 from 0 to 6. This is our solution set. Okay. Okay. Finally, this was the last question. This is all for this video. See you in the next one. Bye.